So with 5.5, we need to do a little bit of reviewing before we get on with 5.5. It kind of connects something that we did a little bit ago with something new. So general solutions. Do y'all remember that phrase? Where we had like A was general solutions and B was particular solutions. It's going to come back to you here in a minute. Don't worry. So if sine of x equals 1/2, if we just wanted x by itself, because that's what we're normally solving for, right? X or sometimes theta. The way we get x by itself is not dividing by sine. Because remember, this is not sine times x. It's sine of x. So the way we get rid of it is by doing inverse operation. So we called this arc sine. Okay, so arc sine. All right, this required that we first figure out what quadrant we should be dealing with. The good thing about inverse principal values was when the thing in parentheses was positive, we got to go to quadrant 1 and everybody was happy and that was great. Okay, and then we use SOHCAHTOA. The opposite is the 1 and the hypotenuse is the 2. So what does that make the third side? Square root 3. And then the big question is, okay, now what is that angle? Which is what we're going to call our reference angle. What's the angle across from 1? 30 degrees, right? And so we'd call that pi over 6 since this is x and we're going to be in radians. If we see a theta, we can stay in degrees. So this is what we called our principal value. Then we needed to write our general solutions, which there were generally 2 of. Okay, the first one was just our principal value, pi over 6, plus or minus, anybody remember?
2 pi n.
2 pi n, good. And this meant that we could go all the way around the unit circle and get basically the same result. Forwards, backwards, as many times as we wanted to. Okay, this second value is really where most of you had a hard time. I think now that I go over it again, it's going to be better. Let's use all students take calculus. Where else is sine positive besides the first quadrant? The second quadrant. So what we had to do is figure out what is pi over 6 in the second quadrant. 5 pi over 6. How are you guys getting that? Are you just remembering? Are you doing a calculation? Yeah, if this is all the way around, or not all the way around, but if all the way to this line is like 1 pi, and I subtract 1/6 of a pi, I get 5 pi over 6. Just for fun, right? What if we had been in the third quadrant? What would that value have turned into? What's 1 more 1/6 of a pi after 1? 7 pi over 6. What if we had needed to go to the fourth quadrant? What could I have written? I could have done 11 pi over 6, but what's the easier way out? Just go backwards, negative pi over 6. So we're going to need to practice that little bit, all right? But those are your general solutions. And then we did particular values and we wrote that out and everything was great. And we're going to keep practicing this. So if you remember, you're like, I was never that good at this. That's okay. We're going to review it. All right, so first thing on this next one, what does just x equal? What did I do over here? Yeah, so what do we call this? Arc cosine or inverse cosine. Now, look at this one. We have a negative ratio, which means I'm not going to quadrant 1. This is where we had to use restricted range. Okay, so I'm going to kind of write this up at the top. SOHCAHTOA. You guys remember this little thing here? The thing inside that little boot what is its restricted range? Actually, first and second, because these are positive in one and negative in another one. The things outside the boot, that's going to be 1 and 2. If you get confused and you fall back on all students take calculus, you can't go wrong. Here's what I mean by that. Cosine is negative in what 2 quadrants? Or, sorry, I'm kind of getting ahead of myself here. That was not a bad question, but we need to go, if cosine's negative, we need to go to quadrant 2. And here's how you can just double check that. Is cosine negative in quadrant 2? Yes. All right, where else is cosine negative? So all students take calculus. So in the fourth, cosine's positive. In the third, so my second value is going to come from the third quadrant. I'm kind of doing this in a slightly different order here just to kind of really talk about these quadrants. If you stick with all students take calculus, you can come back to this every time to check your work. All right, now, ratio time. Adjacent is √3. Hypotenuse is 2. That means the other side is 1. And this again is a pi over 6. That's a pi over 6 right there. It's a 30 degree. So the way we write the answer is we got to place pi over 6 in the second quadrant. We just did that a second ago. What do we get? 5 pi over 6 plus minus 2 pi n. Down here, you have, this is how some of you are going to think about it. You're going to go, that's 7 pi over 6. And some of you are going to want to write that as negative 5 pi over 6. You're going to say, and because we learned lots of different ways to do this. I kind of taught you a few different ways to kind of come up with the second value. So if right there, if you have negative 5 pi over 6, that's totally okay. They mean the same thing. One's going forwards, one's going backwards. All right, now let's do a tangent one. First of all, how would you get x by itself? X. So we were not in the first quadrant. We were in the second quadrant. Like, in other words, whatever you write here has to be in a quadrant where, in this case, cosine is negative because the negative symbol there. You got to pick the 2 quadrants where cosine's negative. All right, so x by itself would be arctan of -1. Okay, the great thing about tangent is we only have one general solution. What quadrant does it go into? Look up here if you need to. The ones right here are the ones that are in the top 2. The ones outside the boot, that goes down here to quadrant 4. So that's where we should go. And a quick check, is tangent negative in quadrant 4? Yes. Okay, ratio for tangent is opposite over adjacent. So if I put that little 1 over a 1, I can go opposites 1, adjacents 1. And what does that mean the hypotenuse is? Square root 2. And what type of triangle is this one? 45, 45, 90. So that's 45 degrees, which is pi over 4, but it's in the fourth quadrant. So how should I write that? Negative pi over 4 would be the easiest way to do it. I feel like I heard somebody say 7 pi over 4, which is okay. All right, and with tangent, we only have 1, but what is it plus minus? Not 2 pi n, pi n. But that's it. That's your only one. Okay, so I know some of you thought this was far behind you. But what I'm really hoping you see is that, okay, I may not remember all this, but it doesn't seem as bad as when we first learned it. Okay, and that's just, it just takes seeing something multiple times. So what we're going to do is we're going to step up the problems just a little bit using some of our trig identities. Okay, the first thing is you're always going to isolate the trig expression on one side using algebra skills and trig identities. We're going to take the inverse of both sides. And then we're going to do everything else that we did before. Okay, there's a little caveat here. When solving equations, we can work on both sides. When we're proving, we have to only work on one side. So this is not the exact same thing as a proof. All right, so first example, is the trig by itself? Nope, there's a 4 right there in the way. So what could I do with that 4?
Divide by 4.
Divide by 4. So I have cosine squared theta equals 3/4.
Square root.
Square root it. I like the sound of that. Square root it. Now, this is kind of weird, but we have a positive and a negative. Do y'all remember that? When you had x squared equals 4, what would x equal? Positive and negative 2. Okay, can we square root 3 evenly? No, so we'll leave it as square root of 3. Can we square root 4 evenly?
Yes.
And you get square root of 3 over 2, which is totally familiar. We've done this. So that's one equation. And we have another equation. They don't always have 2, by the way. Okay, but I just wanted to go ahead and start off with one like this.
Say that one part, but I felt like telling this either.
Well, we haven't done the rest of it yet. Okay, now let's get theta by itself. So theta would be arc cosine of root 3 over 2 and arc cosine of negative root 3 over 2. So how many general solutions am I going to have? 4. I'm going to have 2 for each. It's not really that bad, though, because they're almost the same, just a positive and a negative. Okay, so I'm going to do this down here, and I may erase it, mostly just so you can kind of read my work. You draw your triangle. Actually, I'll just erase this work because we don't need that. All right, so here's where general solutions aren't as bad as you remember them being. We don't actually even have to really get into restricted range too bad. All right, and what does theta mean? It means we can stay in degrees, which is kind of nice. Okay, so let's just start with the first quadrant because that does say positive. All right, and so if theta is right here, then adjacent would be root 3 and hypotenuse would be 2 because cosine is adjacent over hypotenuse. Okay, so a 1 would go in the missing spot. And what would that make that angle? Pi over 6. So pi over 6 plus or minus, oops, I almost did that. I shouldn't write 2 pi n or pi over 6 because I have a theta. What should I write instead? 30 degrees plus or minus 360 n. Yes?
On what our answer problem is what we already did and you're just going on? Or
No, this was the setup and now we're doing the general solutions. So like what I'm doing right now is the answer to part A.
What's after 36?
360n. 360 because that's the same as 2 pi all the way around the circle. All right, we normally have another one. Now, think in this quadrant. Just think logically. Where else is cosine positive? What other quadrant? Fourth. Okay, so what I'm using is all students take calculus. This means everything's positive in quadrant 1, sine is positive in quadrant 2, tangent's positive in quadrant 3, and cosine is positive in quadrant 4. And what's not listed are the negatives. So where else is cosine positive? Quadrant 4. So my question is, what's 30 degrees in quadrant 4? Negative 30. We just go the opposite. That's why quadrant 4 is nice. We can just go in the opposite direction. Okay, so there's 2 of my general solutions. Now let's find the other 2. We don't have to reinvent the wheel. It's still cosine. It's still root 3 over 2, but this time I'm looking in the negative. Okay, so which two quadrants is cosine negative? Right here and right here. So what we need to do is we need to figure out what is the angle that's a 30-degree reference angle in quadrant 2. So basically, what is 180 minus 30? 150. I didn't get 130. 150?
Yeah.
Okay, so in the second quadrant, like if I'm going to draw it really big here, I'm not going to do this every time just because it takes up a lot of space, but if you go to quadrant 2 and you have 30 degrees, how much is the big angle? Well, if we go all the way to the line, it's 180 degrees. So what is this missing angle right here?
I thought you were trying to find inside the green line.
This little angle in here still is 30. It's still 30 because it's still root 3 over 2. It's still adjacent over hypotenuse. I don't really need to like find the reference angle again. The reference angle is 30 throughout this entire problem. I just need to place 30 degrees in the second quadrant. In other words, okay, so if I were to draw this, this would be root 3, this would be 2, and this would be 1. So 30 degrees would go across from the 1, right? So my question is, what is this angle? So if all the way to the line would be 180, and I stop short, 30 degrees, 180 minus 30 would be 150. That's how I got 150. This is why radians are easier than degrees, in my opinion, because with radians, you don't have to do as much calculation. Okay, what's the one quadrant we haven't been to yet? Quadrant 3. Okay, this time, instead of doing 180 minus 30, what am I going to do? Plus, which is 210. Okay, so what I would like to do before we move on to part B, all right, is explain like what on earth we found, because I know some of you are wondering, what does this even mean, right? Okay, all 4 of these equations represent all the answers, which there are infinitely many. There are an infinity number of answers. All of these represent things that I could plug into theta and this make a true statement. 30, and then if I added 360 many times or subtracted 360. If I did the same thing with negative 30, if I did the same thing with 150 or 210. All of those answers are answers to that. So then to do the next part, find the particular values, 0 to 2 pi or 0 to 360. So this is part B. We got to look at all these. What's the smallest positive answer? 30. Some of you are checking out, and I do not suggest it. You got to resist that. Okay, I already told y'all this is the last lesson. Hang with me. This is the last new thing I'm teaching you in 2015. You can do it.
Okay, that makes me okay.
You know what I'm saying? You can do it. All right. Can I put negative 30 though? No. I got to add 360 to it, right? This is what we did before when we did this chapter. We got to add 360, so that would make 330. Okay, these are the answers that are just in the first quadrant. Okay, I'm going to keep moving on because we need to get some more examples done for this to really sink in. All right, so first step always is to get, like in this case, sine x by itself. I see sine x in 2 different places, so what's the first thing I need to do? Like if you had an x on both sides of an equation, what would you do? You'd subtract one of them to the other side, right? So we could do either one. So I'm going to subtract this sine x, And what that's going to give me is negative 2 equals 4 sine x. Okay, I just want sine x though. I don't want 4 sine x. So what am I going to do now? Divide by 4. So what happens when you divide by 4? You get negative, what's negative 2 divided by 4 simplified? Negative 1/2. And so what would just x equal? Arc sine negative 1/2. Okay, that's a fourth of the problem, by the way, like points wise. You can do this. Well, you're not going to stop there. Okay, now we need to draw a triangle and say, okay, well, arc sine of a negative. Here's the deal. If you forget about restricted range, it's actually okay. You've just got to figure out what are the two quadrants where sine is negative. Third and fourth. Okay, it's okay if you write what should be the first one. Like, you see what I'm saying? Like, if you write what I wrote as the first one, if you wrote that as your second one, that's okay. All right, so just pick whichever one of these. I'm going to pick this one because this is the one that we do get by restricted range. Woo, that was a big erase bubble. Here we go. Okay. So we got to say sine, opposite over hypotenuse. That puts a √3 in the missing side. And what is our angle here? Remember, it's going to be 30, 60, 45. It's going to be one of those. 30, right? Pi over 6, though, because this is x, so we got to be in radians. So pi over 6, and I should put a negative in front because the thing is in quadrant 2. Plus minus what? 2 pi n. Hey, write the plus minus 2 pi n even if you're not sure of this. All right, now we got to figure out what is pi over 6 in the third quadrant. In other words, remember this is 1 pi. So am I going to subtract pi over 6 or add pi over 6? Add. Just as a reminder, with angles, we start here at 0 and we go this direction. So here's 1 pi. I'm going to go past it, pi over 6. So that would be 7 pi over 6. And that's the answer to A. This is it for A. That would be okay. Yeah, if you wrote negative 5 pi over 6 here, that would be okay. All right, now, one of these is positive, one's not. So write the positive one down. Okay, the one that's negative, we got to add 2 pi to it. Go off to the side if you need to, if you're not sure what to do. If I'm going to add 2 pi, and I want to get it into really something over 6, what would that be? What pi? 12 pi. So what is negative pi plus 12 pi? 11 pi over 6. So if you need to write it down, write it down. If you can do it in your head, though, that's fine, too. So that's your answer for B. So I think example 2 was a little bit easier than 1. What do you guys think? A little bit.
Both equally hard.
Equally hard. I mean, the whole thing here is it's always going to be hard unless we practice it. But I think for some of you, you're going to do better at this stuff than you did the first time we learned it. Well, it doesn't say, and this is something that's kind of different. The directions used to say find the first 3 positive values, but this says just find the values through the first rotation. So we only have to go up to 2 pi, and if I did try to find a third one, it would be too big. So thank you for pointing that out. I should have mentioned that. Okay, so let's look at example 3. A squared equals 6a. Okay, now, if you divide by a here, you will lose a solution. So this is something you learned back in Algebra 2. You subtracted the 6a so that it equaled 0, and then you factored. Okay, you factor out an a. And if you factor out an a, you're left with an a minus 6. This is just a little bit of Algebra 2 review. So you'd get two answers like this. On the flip side, if you had just divided by a, you would have gotten the 6, but you would have missed the fact that a is supposed to be 0 also. Okay, so you lose half of your answers. Okay, so on example 3, don't divide by sign. You can divide by a number, but you cannot divide by sign. This is what you have to do instead. You have to subtract it over. And this is, by the way, why did we do trig proofs? One reason is so that to prepare you for the next step here. What's something I can do here? They both have a sign. Well, that's okay. I can factor it out. So if I factor out a sine x from sine secant, I'm left with secant x minus 1. We're just going to do one step at a time. We factored out the sign from both pieces. All right, now there's a multiplication sign right here, right? So this means that sine x could equal 0, and it also means that secant x minus 1 could equal 0. So that means that x is equal to arc sine of 0. And what is x equal over here? What would I need to do here? I need to add the 1. And then I would need to do arc secant. Okay, so this one was a little bit weirder. Okay, so I'm going to go ahead and write this up here. X equals arc sine of 0. How do I do that? What do I need to maybe write on my paper? Yeah, the quadrantal angles. This is 0, 1, 1, 0. And for sine, which number are you looking at, the first or the second? Second number for sine. Remember, cosine, sine, it went in alphabetical order. So where is the second number 0? At 0 and at pi. Okay, so we're going to go x equals 0 plus minus 2 pi n, and x equals pi plus minus 2 pi n. Okay, so that's the answer to part A for that one. Now we need to do the secant one. By the way, what happens when you take the reciprocal of 1? What do you get? 1. So that makes this a lot easier. So this is back to this. We look at the first number. Where's the first number 1? Only at 0. So we kind of got a repeat here. Okay? So on to part B. What are our answers? 0. What else? Pi and 2 pi. If you left off 2 pi, that would be okay, since that's kind of like our stopping point. just by adding 2 pi to 0. Like, you want to keep going. If you left off 2 pi, that would be okay. Okay, let's do one more example. Let's do example 4. Okay, this right here is begging for a trig identity to be used. I want you to either look on yesterday's notes or your blue formula card, and I want you to find which trig identity this is. It's one of those sines or cosines, a plus b or a minus b. Which one is it? Which one goes sine, cosine, minus cosine, sine? Sine a minus b? So sine theta minus 40. Okay, now we need to get the theta minus 40 by itself. And that's just going to be our arc sine 1 over root 2. If you're getting confused about restricted range and all that, it's actually okay. You just need to figure out what 2 quadrants is sine, in this case, positive. So that would be quadrant 1, and what else? Hang with me here. 2, exactly. So let's go ahead and draw the triangle in quadrant 1, and then we'll figure out what quadrant 2 should be. So using SOHCAHTOA, opposite should be 1. Hypotenuse should be root 2. Ooh, what type of triangle is this? 45, 45. So I got a 45 degrees, and I can stay in degrees because of the theta. Okay. So I have 45 degrees here. Okay, so let's think this through. So if I had over here 45 degrees plus minus 360 what would that turn into once I add 40 over? Would I add it? I mean, I know I'm going to add it here to make 85, right? Would I also add it to 360 Would those combine? They're not like terms, right? 40 is by itself, 360 has an n, so it's still just plus minus 360 All right, now we got to come up with our other one. Besides 45, okay, if this angle right here is 45, what is the big angle all the way starting at 0? If this is 180, what's 180 minus 45? 135. So we got 135 degrees plus or minus 360 So that would then give us theta equals, and so when I add 40 over, I would get 175. And that's my answer to part A. What about part B? Both of these are positive, so we list them down. If one of these was negative, I would add 360 to it and write that down. Okay? The goal here is not that I get you guys to say this is easy. That's not my goal. The goal is to get better at it each day. Each time we do it, you get a little better than before. You're progressing, you're moving in the right direction.